Everyone, this is my Assignment 2 project, Cloud-Ready Smart Environmental Monitoring System, using Raspberry Pi and AWS Cloud Service. This project upgrades my previous local Raspberry Pi monitoring system into an IoT cloud solution. The system monitors indoor temperature, humidity, and pressure. The main objective is to collect data from the Pi, send it to AWS IT core. Process it using Lambda storage in DynamoDB and provide cloud access through API gateway. This is the system architecture. The Pi and sense height, collect temperature, humidity, and pressure data. The local first API dashboard shows real-time readings. At the same time, the cloud publisher sends the data to AWS IoT Core using MQTT over TLS. AWS IoT Core receives the data, and IoT rule forwards it to Lambda. Uh, Lambda processes the data, and the DynamoDB stores the results. API gateway is used to provide an HTTP endpoint for reading recent data. This is the local dashboard running on the Raspberry Pi. It shows the latest scenario reading and the cloud integrations that here the system shows cloud connected, yes, and the published message count is increasing. This provides that the Raspberry Pi is successful sending data to AWS IoT Core. Here's the AWS IoT MTQ test client. I subscribe to the topic IoT environment Raspberry 1 data. Yeah, here's the received JS1 messages contain device ID, timestamps, temperature, humidity, pressure, score, and so on. This demonstrates cloud data ingestion. This is the IoT rule. The SQL statement is uh, this select from IoT environment by 001 date. When a message receives on this topic, the rule triggers the lamp the function a precise environment reading. Um, then this lambda function precise incoming sensor readings. It extracts the values, checks the status, converts values into DynamoDB, completable document form, and writes item into the environment reading tables. And this is menu Lambda test, the results show store successful. Yeah, which confirms that the lambda function can process state and write it to uh, DynamoDB. CloudWatch logs shows the receive event and sort them. I use these logs to debug issues such as uh, incorrect handler names, missing mm, permissions, and AWS rename mistakes. This is a DynamoDB table environment readings. This stores real reading from the Raspberry Pi. The table use device as a mm, partition key and temp as the sort key, which is suitable for temp ordered IoT readings. This API gateway. I created an HTTP API which routes get readings connected to the Lambda function get environment readings. And this browser page shows the readings API response. It returns recent reading from the NodeDB as JSON. This provides that cloud data can be accessed through an HTTP API. The main local program is mon.py. The few cloud client handles AWS IoT MQTT publishing the cloud backend folder contains the Lambda code IoT rule scholar and IoT place template real certificate and private key fields are excluded from the submitted source code for security. For security, the Raspberry connects to AWS IoT Core using X.509 certificates. The IoT places a policy only allows the device Raspberry 001 to collect the publish to the required topic. This follows the least propagate principle. Compared with the local-only system, the local version improves reliability and remote access. AWS IoT Core handles data ingestion, Lambda data provides server slice progressing, and DynamoDB provides managed cloud storage. API Gateway provides cloud access, and CloudWatch supports troubleshooting. In conclusion, this project implements a working IoT cloud monitoring system. It collects real sensor data, send it to AWS IoT core, or process it with LAMP that stores it into uh, DynamoDB, exposes it through API gateway, and displays local real-time ratings on the dashboard. Thank you for watching.